Good morning, everyone, and welcome to our continuing webinar series for Solid Edge. Today's session is session number 6, and we're going to be looking at the synchronous sheet metal modeling. Just a quick overview, same as before, but if you're new to us, just a reminder that this is a very rudimentary training designed for anyone who does not know Solid Edge. We're focusing on things like managers and supervisors, new employees or prospects, or any interested individuals. This by no means replaces the fundamental course. It's designed to introduce you to the basic capabilities of Solid Edge. And at the end of the course, you'll be able to do some very basic tasks and will be better prepared for our tutorials. As I said, this is session 6. If you want to view the previous ones, they're available on our website. All you have to do is go to designfusion.com and pull up the COVID-19. There's a big COVID-19 orange button or icon on the top left corner. Just click that and it'll take you into our everything we're doing for the pandemic's going on, and one of those of course is our webinar series. And if you click on check out this link here, there's all of our previous sessions along with the links from the pages. It usually takes a day or two to get these up, so we might be a day behind, but they're up there. Usually get up the same evening that we broadcast them. Again, each session is a PowerPoint presentation with embedded demonstrations and or videos. At the end of the session, the user will be shown a page of links to download activities and tutorials to practice, as well as alternate sources for more information. There's also a Q&A session at the end. If you have any session-related questions, please feel free to ask them then. And as I mentioned, the presentation is being recorded for later rebroadcast. So without any further ado, let's get into the basic synchronous sheet metal modeling. Yesterday we did the ordered sheet metal modeling, and today we're going to focus on the synchronous. In terms of synchronous, I would say there's probably more limitations inside of the sheet metal than there are in the part, but as you'll see on Thursday, we have ways around those using integrated modeling. For base features inside of the synchronous, we have the tab and the contour flange. We do not have lofted flanging in synchronous. Currently, synchronous does not support dangling bends, so anything that would be a free hanging or dangling bend would not be considered doable inside the synchronous. And we'll talk a bit more about those as we go through. So similar to the extrude command in the synchronous part, we have the tab command, which can be object action or action object. So basically what that means, you can pick the tab, select the sketch face or the region, and then go through your distances, or you can select the object first and then use the handle or arrow here to create a tab. Okay, if you pick the action object approach, so you pick the command first, obviously a sketch must exist. You do not build sketches inside the command. They have to be built out up front and existing prior to selecting the action. The other nice thing to recognize here is that when you select on the tab command using either method, we have a link right to our material table in the tab command, so you can adjust your gauge properties if you forget to do that before you start the tab command. So in terms of the gauge properties, they're identical. to what we have in the ordered. They both use the same um, gauge tab, same neutral factor, and if you've created an Excel file, um, for our more advanced users, if they've created an Excel file for you to use, for example, in your company, that same Excel file is utilized by Synchronous. Now, along with the tab, we've added a object action only flange command. And what happens is when we go in and pick the thickness edge here, we're given two options by our little handle. We can either go into the move, or we can grab the smaller arrow here and create a flange out of it. As soon as you enter into the flange command, you'll be given your flange options. And you can see that the flange options, although not as robust as you may find in ordered, because a lot of the stuff we do in ordered, we can now do it with the steering wheel. The options preside here for you to go in and make changes. So let's have a look at these two commands. And what I'll do is I'll bring up my, bring in our solid edge. And if you're going to be working in Synchronous quite a bit, remember you can always go into settings, options, and on the helpers tab, say I always want to open my part in sheet metal in Synchronous. So I'm going to go here, go to the open or the new page. I'm going to start with a new sheet metal template. And again, this will open us into our selected template, but it will open it as a synchronous part. In the event that it does open it as an ordered, you always have the option to click on the header and switch to synchronous, or switch, in this case, transition to ordered, or you can transition to synchronous. This doesn't move the features that already exist in there, but we'll see that more when we look at the integrated. So again, inside Synchronous, we don't have a sketch environment, so we don't have a sketch command. We simply start by picking what we want to draw. We can lock our plane by either clicking on the little lock icon or hitting F3, which shows me I'm locked, by putting this in a brown color and moving this up to the top right corner, the little lock icon. I can get a top-down view of my sketch, and I can go and start drawing my shape. I could add dimensions at this point if I wish. So you can go in and do your smart dimension from that wall to that wall, and this wall to this wall. And you can change these values on the fly. Let's make this 165. And then I'm going to unlock this. I don't have to unlock it to do the next step, but I like to unlock it so I don't forget to do it. And then I'm going to, in this case, I'll pick the object first, which puts me into the action mode. Now at this time here, I can go in and type in a depth. It remembers what's in the gauge table, so I'll just use that 1 millimeter depth there, or thickness. And for clarity, let's hide our dimensions and our base reference planes. So there's our tab command. And notice if I now click on the edge here, it gives me these two indicators. I'm going to select this one, and this puts me into flange option here. Let me just hit escape for a second. Now notice I can click here. If I now hit my space bar, it puts me into plus minus mode. I can actually go around and grab all four edges and create a box, if you will, all in a single step. Notice up here we have the options. So I can say I want material outside, or I want material inside, and the box shrinks down. Notice the corner conditions here, which are controlled here. In this case, I'm just going to go back to material bend outside, and let's just drop this 25 millimeters. And very quickly, I've created a little box here. Now, some of the options that you have with the flange, let's undo this. You can go in and do a partial flange, and that just drags this down. And let's say 25 again. Now we can go in and put dimensions from either side, or we can just grab this and maybe we want it to be a bit longer, and maybe we want it to have a slightly rotated inside trim. So you can see very quickly we can create our modified partial flange just using the steering wheel. So that's the tab and flange commands in Synchronous. Although at first glance they seem somewhat limited compared to ordered, with the steering wheel, they're actually pretty much on par. The next command we're going to look at is the contour flange command. Now, there's actually two types of contour flange commands. There's the simple and the complex. And the simple one is usually created when you do your base feature. And we call it simple because even though you're treating it like a contour flange, it's going to actually put it as separate tabs and flanges commands when you create this. So let me demonstrate this real quick so you can see what the simple one looks like. And again, we'll launch our sheet metal. And we do have to have an existing sketch, remember? So we're going to go in and lock a plane here, and we'll get the front view of this plane. And I'll just quickly draw something like we had on the screen there just a moment ago. Hit the A key to go into my arc. And then it automatically comes back to the line for me. That should be good enough. So there's my profile. And we'll go back to the home position. And now we're going to run the contour flange command. Select the sketch. And we can do symmetric or one-sided. Now the thing is, once I place this, let's say 75 millimeters, notice on the Pathfinder here, we have the this is broken into a tab, a flange, and a flange. So it's actually, you can treat each one almost individually in this case. So this is what we call a simple contour flange. It's, for all intents purposes, it's just taking a sketch and making individual components that happen to be attached. So let's go back to the PowerPoint now, and you can see how it's broken it up here. Now the complex flange, this is more when you're dealing with secondary contour flanges. And you'll notice here that what happens is we've taken this and we've put it around the shape here. And what this does is this, you'll see in a moment how this is created in terms of what the Pathfinder looks like. But the thing is, it keeps these all associative to each other. Now, what I mean by that is if I go in and I rotate this face inward, all the other faces will move with it. It's all one connected feature. And as a result, you're going to see in a minute how this looks on the Pathfinder. Now, the one thing I have to point out is that in Synchronous, this would be considered a dangling bend because it doesn't have a linear edge to pull off of. So as we wrap around here, we can do that in ordered, as you saw yesterday, but we cannot do this in the Synchronous. So this is one of the limitations of the dangling bend. And what I'll do is on Thursday, I'll show you how to circumvent this with integrated modeling. So let's bring back our solid edge here. And what we're going to do is we're going to open up an existing part that I have. and I'll show you how to create that synchronous complex one. So here I've created a base feature already, and I've already created my sketch here. So I'm going to go up to Contour Flange. I'm going to select the sketch, click on my arrow, and then I go around and just continue picking the thickness faces of the edges here. And this goes in and creates my contour flange here. And you'll notice that it's actually showing contour flange on the side. And it's giving me a bit of a warning here. So it didn't like something, but it still managed to make the model. So I would have to investigate that. But just to, let's hide the reference plane in the dimensions here, just to show you the capability or what this means by the associativity. If I go in and I move this back a little bit here, everything should adjust with it. And that's why it's giving me that little warning, because it's not going to behave today. Okay, so let's try this a little different way then. Let's, I think I know what's causing this problem. We'll just take this and we'll move this down a little bit and see if we can get it to behave now. Try this one more time. And again, you just pick the continuous edges, accept it. And there, that's much better. You'll notice now there was some consumption, self-consumption going on there. I don't have that red mark there now. I can go in and now we should be good to go. Oh, let's turn off the design intent. And of course, this is being stubborn right now. Try it one more time. Okay, let's do it this way. See if we can get this to move. Huh. I'll have to look into that. You know, when I tried this out before I put these together, it was working fine. So something has happened to cause it to fail. But under normal circumstances, this would behave much better and adjust this accordingly. So we'll have to investigate that. What I'll do is I'll put a video up with the link page showing this working so you can see how it behaves. Apologize for that. It was working earlier this morning, and all of a sudden it's decided that it's going to embarrass me in front of while I'm doing my live webinar. So let's get this out of here and let's go back and continue. We do have the hem command. The hem command behaves the same way as it does in order. The only difference is there's fewer hems to choose from. You have 5 instead of 7 because of the dangling bend situation, but the options are identical. And again, the hem command is limited that it can't go around curves or rounded flanges, if you will. Again, it's because of dangling bends. Just like we do in the ordered, we have the bend and jog command. Again, you need to have the pre-defined sketch in order to create a bend or a jog. And we also do the same close corner treatments. And as I mentioned, the same hems and well, 5 of the same hands, and of course break corners for rounded and chamfered parts. And we also have our cutout features. Now, yesterday I showed you the bend and unbend command. We've actually built that into the um, feature here. Plus, we also have our etch command, stencil fonts, holes, and patterns. So let's have a look at some of these here. We'll go in and we'll create one from scratch. Bring back our solid edge here. And let's open a new one. And we'll just go in and create a sketch to start with. And again, sketching in Synchronous is basically identical to sketching in ordered. You use the same draw commands. The only difference is you're not editing into a sketch environment. Let's go and grab a contour here. And let's make this symmetrical so you can see that we can do it. And we'll put, let's go back to our home view here. And you'll notice here, we can now go in and draw a sketch on this face. So let's lock this, make sure we lock the correct face. Let's just put a sketch. We'll hide the base features just for clarity. Put a sketch across here. And now we can go up and we'll use our add bend command. I want to add a bend using this line here. And then we go through and we select the bend direction and bend angle. And it's just like that. Likewise, we can go here and we'll let's draw another sketch right on this face. Now notice I'm not going to lock this face. I'm just going to go ahead and draw it because it recognized the face by itself. And I can draw on that face. That was the other method for grabbing faces. And I'm going to go up and select the jog command. And with the jog command, I select this. And you'll notice I can pull out the jog and position it like so. Now, yesterday I showed you the bend and unbend. There is no bend and unbend command in Synchronous, but what they did is if we're doing a cutout, it allows us to go in and sort of do that on the fly. So yesterday I think I made a circle cutout like this. And then what I did is I went in and selected the cut command here. Now you notice the cut command has a wrapped cut option here. So I'm going to select that, and I'm going to select this region and this region, and I'm going to accept that. Notice as soon as I accept it, it drops through for me to do a cut. I set that as my through cut, and it automatically rebends. So keep in mind that I did action here, so I picked the action, and then because I select these two, I have to accept it by either doing a right mouse click or an enter before it unbends if I have that option turned on. Okay, so let's close out of here. And let's get rid of this. Okay, deformation features. Very similar in terms of what we can draw, slightly different in the way we do it. For example, the louver is sort of predefined and you fill in the dialogue. and then you can go ahead and place any louver. You don't have to have a pre-drawn sketch in this case. The dimple and drawn cutouts are same dialogues, and basically same creation procedures. The editing is a little bit different, which I'll show you in a minute. And of course, our bead and gusset commands, very similar dialogues, if not identical. The only limit with the gusset command is you can't create a user-defined gusset as of yet. You can only create round and square gussets, which actually covers quite a few of that. Again, keep in mind integrated modeling, we can always utilize the ordered features as well. So let's bring back Solid Edge and have another look at this. And I'm going to go in and open, in fact, let's just create a new part. And we'll go in and we'll create a tab here. And let's go back to our home position. We'll grab our select tool, create our tab, and let's throw a flange on here. So similar to what I had yesterday, we'll hide the reference planes. And now what I want to do is I want to start drawing some deformation features on here. So what I'm going to do, I'm going to first draw my sketches. So let's start, and we'll lock this face, and we'll draw some sketches similar to what I had yesterday. Let's do a small rectangle here. Let's do a curve of some sort here. Okay. Let's go back to our home position. So we'll start with the dimple command, and we'll just put a dimple in here. You can see we have the same options here. We have the inside, outside, and where to measure from, and we have our depth value here. And just to control the distance, we just click on the little gold sphere there, and let's make this 2. And there's my dimple. Drawn cutout. Same idea here. Let's make this 2. Again, same options that we have before in our ordered, and we'll just click here and accept that. The bead, we have the same bead options here. And so let's just make this height. Let's make this, I don't know, let's make this 6.35. And let's make the width, let's make it let's make this 3.2 maybe. And say okay. Select our bead option, and we can select which way we want it to be. And there's our bead. So you can see all very similar to what we had before. Where the big difference comes in here is the edit. If you remember from our previous synchronous, we edit something by clicking on the handle. So I'm going to click on the handle here. Now you'll notice that we have some options. We can change the direction, we can change the thickness, we can change our options. But we also have this edit profile. This is an embedded, what it does, it takes the sketch and embeds it in here. So I can actually go in now and I can modify this sketch by picking up, let's say draw, and what I'm going to do is I'm going to pick up on that point, come across, line it up, and then come here, and then we'll use our trim command. And as long as I maintain that closed profile, it'll go ahead and change the dimple for me. And so we do have, even though it was created with a sketch with our deformation features, it will embed it into the features so you can make edits like that. The louver command. The louver command remembers what you last used, so then you can go in here and say, well, this length, I only want this to be 50, and I want the depth to be 10. And the height, we'll leave it at 5. I'll say okay, and then I can go in and place my louver. If I want to edit that, again, you have the louver handle. You can change the values here and make changes to it. Gussets. Have a quick look at a gusset. Gusset remembers what you last did, so you can go in and make changes on the fly. Let's make this 6. And let's put a radius of 1 on it. And we'll say okay, and let's make the width, we'll leave it at 3. You pick where you want to place that gusset, and you can go ahead and position that gusset. Again, you can do fit, fill, or fixed. So I can put in 3 of these, and oh, operation unsuccessful. It didn't like the way I drew the gusset. So let's go and throw this into a round. Let's make this a little bit wider. Let's make this 4. And there we go. So there's my gussets. Again, I can still flatten these. They just don't appear in the flat pattern. So let's close out of here and go back to our PowerPoint. Now, inside the Synchronous, we do have the option of using the move and rotate commands just like we do in the Synchronous part. Because this is sheet metal, we've added this thickness chain live rule. And what the thickness chain does, it looks at the entire thickness of a chain piece of sheet metal. So if I grab this with thickness chain on, the entire thing moves. If I turn thickness chain off, only this part of the entire chain will move. Do not confuse this with coplanar. It is different, and I'll show you in a minute how different. We also allow you to go in and resize bends. So you can click on a bend and resize it on the fly, or change its attributes. When you are moving and rotating in here, it's important to remember that you don't have to pick the inside and outside face. You only have to pick one face. And the reason for that is sheet metal rule is you have to maintain a universal thickness. So if without that rule, you'd have to pick the inside and the outside face and move them. But now because of that rule, you can just select the single face. And as you pull it out or rotate it, it'll move with it. Also notice that the feature, in this case, a drawn cutout that resides on this tab, it also moves with it because of the feature origin. And so it knows that its feature origin is this face. So if you move this face, it's got to move with it. You can also go in and create persistent geometric relationships that we taught you or showed you with synchronous part modeling. So I can say this must remain parallel with this. And then if I rotate this face, this will rotate with it. So all the dimensioning and relationship rules that we showed you with the synchronous parts also apply to the synchronous sheet metal, as do the move and rotate options. If you remember, there was the 3 options: the tip, extend, trim, and lift. So let's have a look at these just to remind you of them. And we'll bring back our solid edge. And let's open this part here. And notice if I go and grab this here, I'm going to turn off live rules for now. And I'm going to go up here and notice there's our option. So right now it's extend trim. So if I click here, the face gets extended or trimmed depending on where I'm moving it. It aligns with the adjacent faces, in other words. If I change that option to tip, notice now the adjacent faces will adjust and the actual moving face stays the same. Or if I change that option to lift, it's just going to lift that or cut out this face here, depending which direction you put it. So same options that we had before, just a slightly different method of, because you're dealing with a universal thickness face, you can do this with the edges instead of huge faces. I also want to show you that live rule that I mentioned. And so this is a really nice part here. I'm just going to change the background color so it's a little easier to see. Let's go to solid white. Okay, and we'll hide the coordinate. So you'll notice here that if I select this face to move and I have my live rules turned on, notice right now coplanar is working. If I turn on thickness chain, let's turn off symmetry. If I turn on thickness chain, this entire thickness chain moves, and because coplanar is on too, the other side moves. Let's turn off coplanar, and you can see now I just have thickness chain turned off. If I turn off thickness chain, just what I've selected moves. So a thickness chain is anything that's connected like so, the sides, and that'll start moving it as a group. If I turn on coplanar, it's getting this thickness chain and everything that's coplanar with it. So you can see this new live rule that's added in sheet metal gives us more flexibility when we're working with the sides of the part, which we do quite a bit. Now, also, the flat patterning is inside Synchronous as well, and it behaves identical to the ordered flat pattern. That's because flat patterning always occurs in the ordered paradigm. So we'll show you more about this on Thursday, but notice here we have a synchronous features, then we have ordered features, and then we have the flat pattern. Even if you don't have ordered features in here, the flat patterning always occurs in the ordered paradigm. So the basic commands that I showed you yesterday apply in the synchronous sheet metal as well. Now, we've got a little bit of time here, so I want to go back and see if we can rectify that issue. So let's bring solid edge back. And let's close out of here. And we're going to make a brand new part now. And I'm going to go in, and remember, you got to create your sketch. So we'll select the sketch plane, and I can either click on sketch view or control H to give me a top-down look of the view, or I can use my view cube. And we'll go in and we'll just draw an open shape, something like this. And I'm going to unlock my sketch now and go back to my home view, and let's do the contour flange. And we'll just pull that down. And notice even right at the base level here, I can click on here, I can go in and I can adjust this angle. I can make changes using the steering wheel. It really is a nice feature, this steering wheel. Let's hide the base reference planes now. Now, let's go in and create a sketch to use for a contour flange going around the top. Now, remember, contour flange, you want it connected to the edge. So one of the nice little tricks you can do is go use the normal to curve. Select that edge and then pull it right to the end here. And then I'm going to lock that plane to draw something on it. I'll use my sketch view. I'll zoom in. I'll make my shape like so. And we'll get out of there. And now let's see if we can make a contour flange using this sketch going in this direction. And let's work our way around here and accept that. And there it generates our flange. So you can see we've used the contour flange twice, but we only show it once here because the first one was broken up into the individual components. Now let's see if we can make a change to this and see if it behaves this time. And there you go. Okay, so we make a change and that's the way it's supposed to work. So you can see the complex flange now stays that. Now, just a FYI, you can separate the contour flange. If you separate it, it breaks it up into individual components and they no longer move as one. Unless you use live rules. Live rules may keep them together, but you can see I can break them up into individual components as well. Okay, so this is the synchronous sheet metal that I've been showing here. I want to point out one thing that is really important when you know working with synchronous is that your mouse control that you work with, you really have to have good mouse control because synchronous and knowing how to control the steering wheel, that if you're really good with steering wheel and your mouse control, it's a very powerful tool and can be quite useful. At first, it seems a little frustrating perhaps, but it's just getting your muscle memory used to it, and then things will fly. Here is the link page. So we have an introduction to sheet metal parts and synchronous feature tutorial right here. And we have our solid edge sheet metal design self-paced course. And as always, our YouTube channel and our blog. Now, you've seen now both the parts and sheet metal in both paradigms, ordered and synchronous, ordered and synchronous. I've shown them independent of each other. On Thursday, I'm going to show you the benefits of using synchronous in assemblies and also integrated modeling. I believe in some ways that's the most important session to attend, simply because it'll show you, a lot of you are probably wondering, well, what's the difference between synchronous and ordered? I can see a little bit of difference, but until you see that session, you're not going to be convinced that synchronous is the way to go. I've done this, a full-blown training course for synchronous for several years now. And once people realize how they work so well together in the integrated, everything clicks and they can definitely see the advantage. And I will prove to you on Thursday that with synchronous or integrated modeling, you can do stuff up to 100 times faster. It's not just a marketing pitch. I will show you something that I did for a customer 100 times faster than he could do in the original CAD package that he was working with. So make sure you join us for Thursday, if nothing else. So now let's open it up for any questions. If you have any questions, just unmute I've given you the control to unmute your speaker, and you can ask away, or you can send it to the support@designfusion.com, whichever you feel most comfortable with. So do we have any questions?
I got a question.
Sure.
Can you swing back to your slide that had the six different corner treatments in the top?
Sure.
Top right.
We actually have 7, but there's
Okay.
6 here plus this one. This is the mitered corner. Yes.
So the bottom middle
This one.
and or the top right. Those two that
Okay.
are kind of similar.
Yep.
Can you show how to make either one of those function in the contour flange demonstration you were doing there at the end? Is it possible to do those kinds of corner treatments in that where it's seaming?
Well, I can bring up a part that I have that I'll show you the corner treatments in.
Sure.
So let's bring up solid edge again.
I've just struggled to get that style of corner treatment to behave right.
No problem. Let's open up. I'll go back to my sheet metal course here, and let's go into here and go into our parts, and I think this is the part that I want. Nope, sorry. We have an excellent exercise that we do in our
okay.
That's the draft of it. Let's find there it is. And of course it's read only, that's fine.
Now this is ordered. Do these things work in Synchronous the same?
We'll turn this into Synchronous.
Okay.
Okay, now it's Synchronous.
Sweet.
Okay, now don't get ahead of yourself with this. You can take ordered into Synchronous. You can't take Synchronous into ordered. We'll show you that on Thursday. Okay. Yep. So if I go up now and do a corner treatment here, I'll pick the type of corner that I want. And so, for example, a circular cutout was, I believe, that top middle one. Mm-hmm. And I'll go and pick these 2 corners here. And now I can enter in the values that I want. So the circular, let's put in a 3 millimeter, might be a little oversized, but so.
Yeah, what was the bottom middle one? Not the circular, but the one that was that kept the corner a little tighter.
Yep. So we'll go in, and again, we'll do a corner treatment here. And let's go down to, that was probably the
U-shaped?
U-shape or V-shape. We'll do both.
Okay.
Let's go here and here. And then you can go in and you can adjust your gap, your diameter, and you can see they're very similar, but this is the U-shape. So again, just by adjusting this, you'll get a slightly different shape on the U. And let's go do the V-shaped as well. And what I like to do is I'll flatten this afterwards so you can see the resulting cutouts, because a lot of times when people look at this in the formed, but they're used to seeing it in a flat pattern. So I'll show it to you. Let's make this the V-shaped. And we'll set that. We'll leave that. Actually, let's make this 3. Might be a little bit.
So is there a way to keep it, like, without making it a bigger diameter, to shift it up so that it cuts into the corner and doesn't leave that tight line at the top there? Because we don't like to cut our stuff that way.
Yeah, you probably want to use the mitered corner then. I think the mitered corner does that. Let's go in here, select the mitered corner. And the mitered corner probably is the most popular one. And you can put a gap value in there. And too much of a gap. But so let's edit that. Let's just leave it at 0 so I can show you the flat pattern.
Okay.
Okay. And now let's flatten this. Go to Tools, Flatten. Let's pick our top face and our edge. And now you can see here, this is usually what a lot of people use. So, but these, yeah, so they're going to shrink that down for you. So, let me show you one
Can
quick.
you go back to your slide real quick? Because
I'm going to go to even a
okay.
better slide for you because I'll pull
Okay.
up the actual sheet metal slide and it'll show you the different flat patterns here. Just bear with me while I find it for you. And we'll pull up that, let's see, sheet metal. And not that one. I want. Bear with me while I get the right PowerPoint because I've got a really good slide in there that shows the resulting.
Yeah, I was just thinking that I saw in the other slide, that bottom middle and the top right, they had kind of what you've got there in the middle one there as far as what would have been the cutout, but it came all the way back to the corner with that nice radius. And that's what I've struggled to pull off because we're required to actually have a radius at the bottom and it has to cut into the corner there so that we're not tearing and pulling the steel.
Okay.
And I've struggled to get that in Synchronous. And so what I've always had to do is just manually just go to ordered and add it, flatten it out, manually cut my corners.
Right.
Yeah, that U-shaped bottom treatment there. How do you I want to make that happen automatically.
Well, that diameter is the same size as the bend.
Okay, so I just got to crank the diameter up until that happens.
Yep. And see, when you get them flattened, this is what each one. So here we have our closed treatment, and there's our, so here's our U-shaped, here's our V-shaped when you flatten it, and then of course there's the mitered here. Now the mitered works really nice if you want a gap all the way down. But this is, so if we go back.
So in that U-shaped, you see how far back it's cutting in? Is there a dimension that allows you to shift that circle closer, kind of along that line, closer and farther from the corner?
Only the value that you type in. That's the only dimension that they give you.
So for the size of the U, you don't have control of how far it cuts back.
How far it cuts in? No, it's based on. It looks at the. It looks at the radius. Now, that may be a good. That may be a good enhancement request to allow us to take that U back to there. So let's.
Because that'd be perfect if I could shove that U back a little deeper. That'd be wonderful. Because I don't want to make a huge U cutout, but I want to drive it back in.
Go back in here. Let's edit this. And let's change that to 3.2.
What's the offset value do?
Good question. Oh, there you go.
Hey, there's what I want.
There you go. Perfect. Okay.
Okay. That's very helpful.
So give that a try. So yeah, let's see that. That's so let's put this back to 2. And let's adjust the offset. This is one of these undocumented enhancements that they threw in there without telling us. So yeah, there you go.
That's what I've been wanting for years. That makes me happy.
Now, what release are you in?
2020.
Okay, so it's in 2020. I don't remember seeing that in 2019. I could be wrong though, but
I don't remember seeing that
yeah,
before until I just noticed it when it was
yeah.
popped up
So
for
there
you.
you
So
go. So that'll allow you to adjust that. And so let's flatten this again. Let's go back into our flat pattern and have a look. See how it looks. And so there you go. So you can adjust that. Okay.
thank you. That makes me very happy.
Well, that's our job here, is to make people happy. So excellent. Any other questions? No, well, let me bring up the other slide then. Let's return back to turn back to our main slide here. And I'm going to leave it here for a few minutes. If I'll leave this up for another minute or two. If any questions come up, I'll stay on the line. Otherwise, make sure you join us tomorrow morning. We're going to do basic assembly creation, and we're going to show you how to take all these parts that we've made and put them together into an assembly. And then don't forget Thursday, if you're here for the synchronous stuff only, make sure you show up Thursday, and we'll go over some of the benefits of using synchronous. That's it for me. Again, I'm John Pearson from Design Fusion, and we look forward to seeing you tomorrow.
Thanks.
You're welcome.